Hello everyone. Okay, let's go ahead and get started. We went ahead and extracted our encapsulation extraction into another class, so we have logical line utilities. These are utilities that are going to be used for any type of logical line, especially for functions that are repetitive and used quite frequently to save from code duplication. So inside of types, we're going to get started on our next type, which is an operator line. And an operator line is going to allow us to declare and modify variables directly. What an operator line will do is it will start with a variable. So it'll start with some sort of name, and then we'll have some type of operation. In this case, I'm saying equals. So a variable equals 10. So I've just made an integer. This would be an operator line. Another example of an operator line could be plus equals and what have you. It's any sort of operation like you would think of. Plus, minus, multiplied, divided by, any sort of assignment or modification. That is going to be one of our operator lines. So this is what we'll be making today. Through the use of an operator line, we'll create or access variables and then assign and modify their values. To do this, we of course need a new logical line, so let's create a C# script called LL and make it operator. Let's of course start inside of the logical line's namespace and inherit from the iLogical line interface. And let's implement that interface so we get the keyword execute and matches functions. Next thing we want is the regular expressions namespace because we will be using that to identify variables and operations and such. And we'll also want the system.link namespace. Okay, so we're not actually going to have a keyword for our operator line because it's going to start with any kind of variable. So we're going to leave that as not implemented. What we will be doing when we check for if this matches something, we're going to be making sure that it has both a variable and an operator assignment to it. So we're going to be looking for that equals or that plus equals or something, and also that it has a variable inside that line. Now, in order for us to do this, we're going to have two different logical lines that work with variables. So we'll have one, which is this one, the operator line, and that will assign and modify variables. And then we'll also have the condition line, which will look at the variables and determine if the expression is true or false. That way we can execute different lines under different circumstances. Now, both of these are going to use the same thing for identifying these variables and identifying these operations, and that's going to be an expressions class within inside of our logical line utilities. So let's go back there real quick. We've got our encapsulated data, and that's all good, so I'm just going to minimize that. But we need a new class here. This is going to be a public static class called expressions. Now, the first thing that we're going to want is to define what sort of operators are available to us. Again, these will be those mathematical or concatenative statements that we can do for subtracting, adding, or just assigning a value. So we want to define all of the ones that we will include logic for. And we won't do this in a list, but we'll do it in a hash set, because the way that we'll look up these values when checking for it in the matches statement, it's using a hash set. It just has a faster compute time than if we were to use something like an array or a list. So if we have many of these things, then it'll just be faster in the long run. It may not be anything that you would notice, but it is an optimization nonetheless. So let's go ahead and start with a public static hash set. And this hash set is going to be containing strings. We will call this our operators. And that will be equal to a new hash set. And inside of it, we'll go ahead and define the ones that we will allow ourselves to work with. So the first one, of course, is going to be equals. Now, we'll also have minus, so we'll be able to subtract something. We will have plus, so we can add. We will have the multiplication symbol, so we can multiply if need be. And of course, we will have the division, so we can divide. Now, another thing we can do is we can do assignment and an arithmetic operation in the same way, just like we do with coding. So we'll do minus equals as another one. And let me get my comma right outside of there. We'll also have plus equals. We will have multiplied equals, and we will also have the division equals. So your basic operators here. We're going to make sure that we can include all of these. Okay, so we have our operators defined. And now when it comes to working with two variables where we will have one on the left and one on the right and some sort of assignment operator in the middle, we want a way to be able to find that and just quickly split the left from the right and take out the operator in its own little thing. So we'll go ahead and define those down here in a regex expression that will find wherever these assignment operators are inside of our string. This one will be a public static read only because we don't need to change it, and it's just going to be a string for our regex pattern. So I'm going to call it regex arithmetic. And this is going to equal a regex value, which will just show us anything that will do math and assignment at the same time. So we will have our first option. It can either subtract, it can either add, it can time, multiply, it can divide, and we can even do a equals equals comparison, but it must be followed by equals. Okay, there's our basic regex expression there. We're also going to want another one that we can use to identify if a line starts with a variable and is preceded with an assignment operator. So we'll make this a public static read-only string, and this will be a regex operator line. This will match true if what we're looking at is indeed an operator line of some sort. To save some time, I'm just going to leave these in the description. So this is our regex operator line. This will just identify if at the start of the line we have a variable which is preceded by any sort of assignment which is preceded by a space, and then anything after that. And the last one we'll want is something that we can identify all the variables with throughout our entire string in case we have multiple variables, as we'll be able to add variables together, and when we get into conditions, we'll be able to have multiple variables in one line. So this regex will identify all the variables that are inside of our string, so that way we can inject the right values. So jumping back to our operator line, let's go ahead and remove this throw not implemented exception there, and let's go ahead and define the matches that may be in this line. So we'll say match equals regex.match, and we're going to be looking at line.raw data. We'll get just all the unfiltered data here, .trim, so remove any white space, and then we want to look it up by the pattern of our regex operator line. Now that's defined within the expressions class, so let's make sure that we are using static dialog.logicalLines.utilities.expressions. And then what we'll be able to do is reference our regex operator line. So we can find out if this has a match, and we'll just say return match.success. That will tell us if we have a variable that is being assigned something. So if that's true, we'll go ahead and try to execute. So let's go ahead and start by making sure we've got the trimmed line. So string trimmed line, which is just removing all the white space from this raw line that we're working with, because we just want to apply it straight from the file to this expression checker. And now let's split all the parts that will match all of the assignment operators that we might have. So like our plus equals and minus equals, we want to separate the variables from the operations. So string parts will equal regex.split, and we're going to split the trimmed line by our arithmetic regex expression. Once we've got that, we know if we have multiple parts here. So we should, at the very least, have 3 parts. That should be the variable on the left-hand side, the operation in the middle, and the value on the right side, or more, but we must at least have 3. So if parts.length is less than 3, then we know this is invalid. So what I'm going to do is I'm going to log an error statement, and I am going to break out of this coroutine. Now, if that's not the case, then let's go ahead and split our variable by the operator and whatever remaining parts there may be at the end. So let's get our variable. our string for the variable is going to equal parts0 dot trim, and then we're also going to remove the little symbol. So we'll go and say trim start and specify the character of our symbol. The next thing we want is actually the operator. So string operator is going to equal parts1 dot trim. It looks like I can't use the actual operator word, so we'll just go OP. And then we may have multiple values at the end, such as if values are concatenated together. So let's just get all the remaining parts. We'll have this as a string array called remaining parts. And this is going to equal a new string, and we'll make it an array of our parts length -2, taking out those first two items. So it'll just be for all of the remaining parts. Now let's go ahead and copy all of the remaining parts into this newly created list. But we're going to need the system namespace because we're going to use the array class. So using system right up above, and that'll prepare us here. So we'll go and say array.copy. And what we're going to copy is we'll take our parts, we'll set the start index to 2, and we'll go ahead and specify remaining parts as the destination array. And let's go ahead and put destination index, so we're starting at the beginning, and go ahead and say parts.length -2 to carry us all the way to the end. And now comes the part of figuring out what the value is that we're actually applying to this thing. So if we have multiple values in here, then we'll be adding or subtracting, performing all the math against them. But we just need to get the actual value that's being assigned to this variable. So to do that, let's create a function inside of the utilities class called calculateValue that we can call here. For now, let's go ahead and say object value. Since we don't know whether it's going to be a string, integer, boolean, what have you, the variables can be of any type. So object value is going to equal calculate value, which we don't have yet, and we'll just be passing in our remaining parts. Now to generate that, let's go to the utilities class, and inside of expressions, let's make a new function. This is going to be a public static object called calculate value. And it's just going to take a string array of expression parts. So as we start this function, we're going to want to create 3 lists which will contain our operand strings, which are the values which we'll be adding or subtracting, doing whatever together, as well as the operator strings, so we know what operations to perform on each of the operands, and then a list of objects for all of the operands themselves. That will be these 3 lists here. The difference between operands and operand strings is we're just going to grab the string values, and then we'll worry about converting them into their actual values later. So the first thing is we're going to loop through and separate all the operands from the operators. In case you're unfamiliar with the terminology, an operand is anything that is having an operation applied to it, and things like equals and plus equals, those are our operators, just like we defined in the hash set. So we'll start a simple for loop to go through all of the expression parts. And then we want to get whatever part we're working on. So string part equals expression parts I, and let's just go ahead and trim it and make sure there's no white space. Otherwise, that'll throw off our calculations. Now, let's see if it's empty. If part equals string.empty. If it's empty, we don't want to do anything with it. We just want to continue on to the next part. Otherwise, we need to compare and see if our operators contains whatever we're working on, so we know that this is an operator string. Otherwise, if it's not, then we know it's an operand and it's a value, and we need to extract that value. So let's go ahead and check. If operators dot contains the part that we're looking at, then we know that operator strings dot add part is going to be what we have to do here, because this is an operator. Else operands or operand strings add part. So we get our operators and we get our operands. So now we can move on here and go ahead and figure out what these values actually are. We'll run a for each loop on each string inside of our operand strings and then extract the value somehow. But let's do that in a separate function. So let's just go ahead and make a function right below here, which is going to be public static object, and we'll call it extract value. Actually, that doesn't need to be public. That's internal, so it's going to be private. But what we are going to take is we're going to take a string for the value that we're looking at. So this method for extracting a value is going to extract the actual object value from any sort of string. This is going to handle variables and whatever type of values that those variables could represent. So let's go ahead and check one thing first. In case we're working with booleans or something, we want to be able to negate that. Such as if we declare a variable to equal true, then to see if it's false, we could do if variable equals false, or we should be able to negate it and do it even quicker and just say get the opposite of what this variable's current state is. So we'll call that negating the variable. So let's go ahead and see if this variable is negated. Bool negate equals false by default. And let's go ahead and check. If value dot starts with the exclamation point, then we know that this is negated. So we'll say negate equals true, and then we need to take that off of there. So we'll get the substring at the first index, so that way we skip right past this operator and we just get the value. All right, so the different kind of values that we can extract. We can find variables, which means we will identify a variable by this little symbol here, this $sign, and then we know that it's a variable, so then we need to look in the variable store in order to extract the value. Otherwise, if it's just some other item and it doesn't start with that, we know it's not a variable, and we can just try to parse it and figure out what that value is. So let's start with a variable. If our value dot starts with the $sign symbol, then this is a variable, and we need to look at the variable store. So let's go ahead and just get the actual name of the variable, so that way we can send it to the store and get the right value. String variable name equals value dot trim start, and we're going to take that variable symbol right off of it. So we need to check if the variable store actually has this variable in it. Now, our variable store doesn't have a way of checking just if a value exists, just trying to return it or not. Let's go ahead and make a way to actually get a boolean that will tell us if it's in the store or not. So public static bool, and we'll call it has variable, and we'll pass in a string for the variable name. So let's go ahead and grab the parts here. So we'll say that well, actually, we can just copy this right up here from extract info. And I will just make that name right there. Okay, so we get our parts, we get the database, and we will correctly figure out if the variable exists. So now we can just go ahead and return db, so it should be a specific database or the default, .variables.contains key by the variable name. And then we can go ahead and check it here. Let's go ahead and check if it does not contain the key. So if not variable store.has variable, then we'll pass in the variable name. If it doesn't, then we're going to log an error and just exit. This will be just logging an error saying the variable doesn't exist and returning null. Otherwise, we should try to get the value. So we'll go ahead and say variable store.try get value, and we're going to get it by the variable name and cast it out to an object called val. Now, if this value is a boolean, then we need to negate it. Otherwise, we just need to return it. So if val is bool, and we'll call the boolean, that way we can negate it, we'll just call it a bool value, and we are negating then we'll return not bool val. So we'll flip it. Otherwise, we just go ahead and return val for whatever type of data it is. So that's how we take care of our variables. Now let's go ahead and do the same thing for, let's say, if we have a string. So if we have quotes around multiple words, then we're just going to return everything inside of there as a single value. So let's say else if value dot starts with, and we need to check for the backslash quote if it starts with a quote, and value dot ends with that quote as well. So if it starts and ends with a quote, then we know we have a string, and we will just return our value dot trim, and we're going to trim off the quotes. So we just get the whole string inside of the quotes. Otherwise, this is some kind of other variable. So let's try to figure out what that is. We can try to parse it as an integer, as a float, as a boolean, or just return it as a string if we can't figure out what it is. Let's first try to get it as an integer with int.tryParse, casting it out to an int value and returning that if it's true. Secondly, if it's not an integer, let's try to get it as a float. So if it is a float, then we'll parse it as a float and return the float value. Thirdly, let's go ahead and try and see if it's a boolean by using bool.parse. And we'll get the value, and then for a boolean, let's not forget to check if we're negating it. If we are negating it, return the opposite of whatever the bool value is. Otherwise, return the value that we got. And otherwise, let's just go ahead and straight up return the value, because that's going to be just our string, and we'll just assume that is a string. We could add more parsing in here if you want to use different types, such as maybe we could even assign characters to variables, but we'll stick with this for now. And that will successfully extract our value, whatever it is, whether it be a directly provided value or a variable. Now where we stopped off at calculate value, we were going through each one of the operands and going ahead and extracting that value. So for each one of those operand strings, let's say operands.add, and let's extract the value of the operand string. So whatever it is, we now have the values that all these operands represent. And now comes the point of running the calculations for our math, or if it's strings, we'll just be concatenating them together or what have you. But rather than make this a very long function, let's go ahead and separate the things that we're going to need. So we're going to start with multiplication and division. So we'll try to follow the PEMDAS rules for, parentheses, expression or exponent, multiplication, division, addition, subtraction, that whole school thing. So we'll try doing multiplication and division first. We're not going to do parentheses or exponents because though we're including all of this in the dialog files, we don't want to get too carried away with it. We want code to be code, and we want dialogue to be dialogue. But this will give us the ability to just add a little bit of extra dynamic capability to those files. So keeping it simple. Let's go ahead and start with multiplication and division first. So private static, and we don't need to return anything here. We're going to do a void, and we will call this run division and multiplication. Actually, maybe I will call it calculate value. So we'll go ahead and use the actual name there, but underscore it, and then declare it as a part of that. Okay, so calculate value, division, and multiplication. And what we're going to want is we're going to want the operator strings, so we know what operations are taking place, and also the operands. So we want a list of strings and a list of objects. So I'm going to copy that, put that as my first parameter, and then just make operands a list of objects as my second parameter. So here we are. Then let's go ahead and say calculate value for division and multiplication, passing in our operator strings and our operands. And then we can copy this. And we'll change division and multiplication to PEMDAS, addition and subtraction. So then calculate addition and subtraction from the operator strings and the operands. That way it's very clear what we're doing here. Now, as we run through these, what they're going to be doing is they're going to be performing the calculations and removing the operands from this operands list. So at the very end, we're only going to have one operand remaining, and that's going to be the final value. So after we've taken care of calculating all of that, let's just go ahead and return operands 0, the only one left, and this will have all of the values assigned to it. So let's start with division and multiplication. We'll start with a basic for loop, going through all of the operator strings. And then we'll get our current operator string that we're working on. So let's check and see what kind of operation this is. So if operator string equals our multiplication, or the operator string equals our division. If it's one of these, then we'll go ahead and do something with it. We need to go ahead and get the left operand and the right operand and add them together. Now, I'm going to assume that when we're doing this, we're not trying to multiply strings together. So I'm not going to implement any sort of error checking or float parsing before we get started on this. I'm going to assume we know what we're doing and we're multiplying and dividing numbers by numbers. So if there is an error, then I'll just let the default Unity error handling take care of that. So let's go ahead and try to convert these things into doubles. That way, if they're floats or if they be strings, they're all going to multiply and divide appropriately together. So we'll declare a double for the left operand, and this will be, we'll use the convert class, so convert to double, and we're going to try to convert the first operand. And then double right operand equals convert to double operands I plus 1. So we get the left and the right as a number. Now let's go ahead and check if we are multiplying. So if operator string, not operators, if operator string, there we go, equals multiplication, then all we're going to do is we're going to say that operands I, the first one, is equal to the left operand times the right operand. Otherwise, this is division. And I will implement error checking if the right operand is 0 because we can't divide by 0. So if right operand equals 0, then we'll go ahead and log an error. So I'll just log the message, can't divide by 0, and return because, yeah, we hit a major no-no. Now, if that's not the case, then we'll go ahead and say operands I equals left operand divided by the operand on the right side. After that, well, now we can go ahead and remove the old operand, and we can continue on. So we'll go ahead and say operands dot remove at, and we're going to remove it at the index of I plus 1. So that way we remove the right operand because the left one is the one that's being updated. So we remove the right one, and let's also remove the string of the operand. So operator strings, and we're going to remove at the index that we're working on. So we're essentially just updating these lists, that way we can continue on with the loops, and we're just removing all the values that we've already processed. And then let's go ahead and say I minus minus. We need to decrement our counter here because since we're removing, we are decreasing the list size and we don't want to get an index out of range. So we'll go ahead and decrement there, and that's it for multiplication and division. Now, how about addition and subtraction? We're going to be doing the same thing, running our for loop and then getting the current operator string. And then we just want to check if we are adding or subtracting instead of multiplying or dividing. If we are adding or subtracting, then we're going to go ahead and convert our left and right operand to doubles. That way we can perform the right calculation on them. So right here, let's go ahead and check if our operator string, in case you're wondering why I copy and paste sometimes, it's because of that. When I try to type fast, it does not work for me sometimes, and today is one of those days, so there might be a lot of copying and pasting. So if our operator string equals the plus symbol, then operands, right there, equals the left operand plus the right operand. Otherwise, our operands I equals left operand minus the right operand. And then after we've taken care of that, we will go ahead and say we'll remove the operand that we have taken the value from. We'll remove the operator, and we'll go ahead and decrement so we can continue on with the loop at the right index. And that takes care of our addition and subtraction, as well as our multiplication and division. So with this, we can calculate the values of our expressions here. And with that, we have enough to head back to our logical line and continue off assigning a value to a variable. So our object value, this is what we've been working in the execute command for our operator. So we've got the variable, the operator, and all of the remaining parts for our values. And we now have the final value that needs to be applied to our starting variable. So we're done with there, and let's just make sure that our value is not null. If there were any issues, then we might not have a value. So if value equals null, then we're going to yield break, and we're not going to do anything. Otherwise, we need to go ahead and process our operators. And at the very end, we need to go ahead and assign the value to the variable using the operator that we have defined here. So we'll handle that in a different function, which will be a private void called process operator. And this will take in a string for our variable, which is what is receiving the value, a string for our operator, which is how we're applying it. Of course, I can't use operator, so it'll be OP, and then an object for the value that is being applied, since it could be anything. And so we'll just say process operator, passing in our variable, our operator, and our value. So when we go to process our operator, we are assigning the value to the variable. Before we do that, though, what if our object is a string? When we are checking this string inside of calculate value, if we see that it's contained within quotes, then we are automatically just shooting it on ahead. That's the value because it's a string. But what if that value actually contains variables? What I mean is when we're extracting the value, only if it's a variable, we're going through and injecting them. But if it's a string, then we're just returning the actual string there. This string might actually have variables in it, so we need to make sure that we inject the values of the variables in its place. That way, if we were to set some kind of status or something as a string heading to destination, then it would not actually inject the destination, but that's what we want it to do. We want it to find every instance of a variable and then inject the actual value from the variable store into the string. That way it can be applied correctly to our variable. So if we're going to be injecting this data in there, then that actually sounds like a good job for our tag manager, which is why we turned it static in the previous part. So before we go ahead and return the value, we're going to use tag manager to inject the variables. So we'll call tag manager dot inject, and we're going to say inject variable. So we'll inject the variables into the value, and then we will return the value trim. Let me make sure that I encapsulate everything into the brackets. There you are. So inject variables. Let's go ahead and generate the method for that and go to it. So in our tag manager, this is going to be a public static void for inject variables, and all we're going to do is we're going to look for any variables in here and inject them into the text. Why did I explain that? That's obvious. Now, what isn't obvious is how we might go about this. You might think that we may be able to just use text.replace and replace tag like we did it with tags, for our variables. However, tags are unique in the fact that they have to begin and end with a symbol, so you know the exact string you're replacing. Now, we know the exact variable name that we're replacing, but what if we had an instance like this? What if we had a string and we defined a variable called env for environment? And maybe we decided we were going to make another one, which was called envelope. So we've got env and we've got envelope. They're two separate variables, but if we just use string.replace, then it's going to find env and it's going to replace it with the value, maybe department, whatever. I don't know what that would be. But then it'll find it here as well. So then we would wind up with departmentalope. That's not what we want. So we need to be looking for the variables, and we need to make sure that we inject them into the right space and not just use string.replace. Now, in order for the tag manager to find these variables, it needs to know what to look for. We did define within the logical line utilities the regex pattern that identifies the variables. So I'm actually going to remove that from the logical lines, and we're going to take that into a place that they can both access, and that is the variable store. The variable store will define its own pattern for the variable IDs. And that means the tag manager can reference the variable store to look for the presence of any variables in the string that has been provided. So the first thing is we're going to get a list of matches, and this will be for our value, the string, and we're going to match it against the regex value within the variable store so we can find all of the variables. Next thing we want to do is we want to iterate through this loop, but we want to start at the end of the list and work our way back to the beginning. The reason for this is because we're not going to be using string.replace for the reason that I mentioned earlier. Instead, we're going to be taking the start index of the variable and the end index of the variable, and we're going to be removing all of that and injecting the value. So if that value, say, is 13, we now have a shorter string. And if we go from beginning to end, we'll be messing up the length of the string, then we'll be messing up our orders. But if we go from the end to the beginning, then it's all going to fall in line perfectly. So let's go ahead and get the match that we're currently looking at. That first match is going to be the first one defined. And we just need to remove the variable identifier from this thing. Now, as many times as I've used that, let's declare it as a constant in the variable store. I'm going to make a public constant character for the variable ID. And that's just going to equal the $sign. So in the logical line utilities and extract value, when we look for the variable, let's just go ahead and reference that from the variable store. The variable store dot variable ID. And we'll also reference it when we trim it. So the variable store dot variable ID. Now, if we decide to change it later, we can do so pretty easily. Plus, it's good to just minimize those hard-coded strings and characters wherever possible. Inside of our logical line for the operator, I'm going to go ahead and replace that there as well, too. So variable store dot variable ID, and that was the only place we referenced it. So now we're good. And then from this match, let's go ahead and grab the variable name by removing that variable ID from it, and we have the raw name only. So let's try to get the value. If not variable store dot try get value, let's just try to get the variable name and cast it out to an object for the variable value. If that's not the case and we don't have one, then let's go ahead and log an error saying that it was not found. Now, if not, if we do have that variable, now we need to remove the string where this, remove the part of the string where this variable identifier is and insert the value into that point. Which means if we encounter this variable, then we want to remove 1, 2, 3, 4, and then insert the value of whatever that was. So we'll say int length to be removed is equal to the match dot length. So let's just check if match dot index plus the match dot length is greater than the value dot length. If it is, then we're going to remove the value dot length minus the match index. So if this is the last one and it's right at the edge of the string, we're just going to remove everything from where it starts to where it ends. Now let's go ahead and change it. So the value, the string that we are working with here, this is going to equal the value dot remove, and we're going to remove starting at the match dot index, that's the starting point, and we're going to remove as many characters as there are in this variable that we've just found. And then the value will equal value dot insert, and we're going to insert the actual value of this variable. So match dot index and the variable value dot toString. Once we're done, well, this actually needs to be a string. We need to return a string. So we will return the value if we can't find a variable. Actually, no, we won't either. If we can't find a variable, then we'll just continue and we'll skip past that one. So we'll still have that part inside of the string. It just won't be replaced with anything. But at the very end, then we'll go ahead and return value with whatever has been replaced in there. Now to handle this automatically for us, when we inject, say if we're working with dialog, dialog is always calling inject. And maybe we'd like it to automatically try to inject the variables too. So let's just go ahead and add two booleans in here so we can control that. So inject tags equals true. By default, we should always be injecting the tags. And bool inject variables equals true. We'll want to inject both of these. So I'll make a new private static string. I'll make it public, just like I did for the other one, so I can access either one whenever I want. And we'll say inject tags with the string for the value. And what we're going to do there is just take this and pop it in here and return the value. So just going to return value, replace text there. Okay, so we have a separate instance for injecting tags and injecting variables. So what that means for us is now we can go ahead and check if we need to inject any of this and go ahead and take care of it. So if we are injecting our tags, then we want to make sure that our text equals the text, or our text equals inject tags text. And if inject variables, then text equals inject variables. And so if I look inside my database, inside of the DB numbers database, I got a variable called float1, which has the value 7.5. Now, if I were to take this 13 and just change that to that variable name, which would be the DB numbers database dot float1, then we should see that get injected in there. And to see tags work, I'm also going to put in the main character tag, so that way we can get the main character name. So variables and tags should work here. In order for this to work, since this is not part of the same script right now, none of the testing scripts are, I need to run the variable store testing first, that way it creates the variables, and then I need to run dialog test, so that way it can detect them. We could change the script execution order, but there's no need to do that for testing scripts. So now let's go ahead and run the test dialog. There we go. First variable is 7.5. Second variable is the character name. What that means for us is we can take variables and we can go ahead and fill that text that will be returned as a string to the operator. So if we go back to the extract value function within the utilities and go down to where we are returning the string, then let's just make sure that we say that value equals the tag manager dot inject variables value, and we should get the correct variables inside of the string. And to do that, we're going to go ahead and just check first if the value exists. If it does not exist in the variable store, then we need to create a new variable and assign it the value. So no matter what our value is, whether it was a variable or whether it was a direct value passed in, we have the correct, whatever it is that we're trying to assign it, we have the correct value to put into this variable. So let's just see if it exists or not. So if variable store dot try get value, and we're going to try to get the variable and cast it out to an object with the current value. Okay, that's if it exists. Let's just go ahead and see what we'll do if it does not exist. If it doesn't, then, well, if we look at our variable store, then when we call try get value, if it does not exist, then we're just returning nothing. So we're not going to be creating it, so it just returns nothing. So we need to make sure that we create it and assign the value if it's not already in there. To do that, we'll just say variable store dot create variable, and we're going to create it by this variable name and pass in the value. Now, if it does exist, then we need to set that value. And setting the value is not simply, it's not as simple as just setting the value, because remember we're working with our operator here, which could be minus, plus, minus equals, times equals, so we need to evaluate what that operation is and make the correct assignment based off of that. So we'll have another function that we're going to run all of that in as a private void, and we'll call it process operator on variable. So if we do have the value, then we'll go ahead and process the operator on the variable. And the thing that we're going to take in is the variable name. We also want the operator that we're working with, so we know how to assign it. And we want the value that we want to assign it. And we also want to know what the current value is. So we can pass all of that in right here. So we pass in the name of our variable, we pass in the operator, we pass in the value that's being assigned, and the current value that we retrieved from trying to get the variable here. So what are we going to do with our operator? We know that there are only certain kinds of operations we'll perform, so we can do this in a switch. And we'll just pass in the OP as the operator. So let's evaluate our first case. The first case is if we're just assigning it, and that's going to be with the equal symbol. So if that's the case, then variable store dot try set value, and we're going to set the value of variable to the value. That's all. And then just break. So next case. Next case is going to be if we are adding to our variable. So if that's the case, then we'll take our variable and we'll do the current value, and we could do plus the value that we are passing in. But you'll notice that that gives us an error because objects, well, we don't know what those objects are. They could be integers, floats, or strings, and we need to figure out what they are. So yes, we'll make another function that's going to handle the concatenation for strings or the addition or what have you for what's going on here. So private void, and we will call this concatenate or add, because this could be a string or it could be an integer. So instead of passing in that value, we'll pass in the value that's returned from concatenate or add, and we'll give it the current value and the value that's being added to it, which just means we need those as parameters in this function. And what this function should return is an object, so that way it can be applied to the variable. Okay, so what we're going to do here is very simple. We just need to check if it's a string, and then we're just concatenating, and if it's not, then we're going to convert our item into some sort of number, and then we'll perform the regular addition. So let's go ahead and check. If value is string, then let's go ahead and return the current value dot toString plus the current, or plus the, rather, the value. If it's not, then we need to convert our numbers into some sort of number, a double or something, and then add them together. We're going to use a system class called convert, and convert whatever the value is to a double. That way, no matter if it's an integer or if it's a float, they can be added together and we won't have any kind of parsing issues. So if it's not a string, then we're going to return convert.toDouble, and we'll take the value and we will add that to convert.to double current value. Great. Okay, so now I'm just going to copy this and make one for minus equals, which is going to be, we'll do the try set value for the variable, but we're not going to do concatenate or add, because we're not going to be subtracting from a string. Well, yeah, no, I'm not going to do that. We'll have concatenation for strings, but we won't have minus for strings. So we'll just go ahead and do the math right here. So convert.to double, and we'll take the current value plus, not plus, minus convert.to double, the value being applied. And I'll copy that. We'll make this for multiplication and for division as well. So we'll just change the operator here and there. This will handle any of our operator assignments. Now, if there's something other than that, which will just run as a default, so for anything that doesn't match any of these other cases, then we'll log an error and say that this was an invalid operator passed in, and we can troubleshoot from there. Just with a simple debug statement will take care of that. Okay, and that may be it. I believe we are through there. So our execute is going to find all the parts. We're going to calculate the value, and then we're going to process the value and assign it to the variable. All that's left now is to test it, and we'll do that through one of our dialog files. Let's start with a simple test. We'll go ahead and take our little example variable, money, and declare that to equal 50. And I'm going to use both the variable store testing and the test dialog file here, just so I can run these two together and see the variables inside of the variable store. So I'll keep this one active first because I want to run this later. But let's go ahead and start it and just see what we've got. Okay, so we should get this money variable come into the default database. So if I queue and refresh, you can see it is not there. Now let's clear it. Okay, so actually I'm going to print it once so we can just see the difference. Now let's run test dialog file. Okay, run line money equals 50. So question, did that work? Let's press Q. Default hello, variable money equals 50. There we go, we can see our variable is in the variable store. Now after we declare that variable, let's also subtract it. So money minus equals 55. This should run the subtraction operation on our variable, and we should see it process correctly. And when we run that, I can see that variable money is now equal to -5. Nothing like being in debt. Okay, now that we can see that working, instead of running it through the database and checking to see what the variables are there, I'm going to do it through dialog. So we'll have the narrator say, you have money. So we should get the value of money injected in here. But I'm also going to test another operator and do multiplied by 135, which means the IRS was not here. Okay, here we go. Yeah, so we can see that working. There's just no sort of rounding on that number, so it's big. But we can see that float is working with our integer there. So we're good. Next, how about a boolean? We'll first define light switch as true, the narrator will flip the switch, and then light switch will equal the negation of light switch, which should be false. And then we should see light output to false. So right off the bat, we can see in our default database, light switch is true, narrator flips it, and then light is on is false. If we look back at our database, the light switch is set to false. Now how about something a little more interesting? Let's first pop up the input panel and ask for our name. Then let's make a name variable with a string containing the last input from that input tag. And then we'll have the narrator declare who we are using that variable. And then we'll run string concatenation to add from outer space onto that name. And finally have the narrator tell us who we are again. So we get our input. I'm going to put Avira in, and then... Oh, well, you know what that means. I injected variables, but not tags, to the strings. It's a good thing we ran through this test, huh? That's just as simple as coming back to where we inject the variables to our value, only we're going to say inject tags. And by default, inject tags will also inject variables. So let's just make sure that those are true. So inject, why is that not auto-populating for me? Because it's inject, not inject tags. I'm going to make that private so I don't make that mistake again. And we'll just be able to reference these two through the inject function anyway, by referencing these booleans. And that means I'm going to change inject tags to inject. We'll take the value, and we'll say inject tags is true, and inject variables is true. Even though they default to true, this helps me understand that's what this line is doing. So let's give this another go, except there we are. You are the amazing Avira. Okay, now you are from outer space. Yeah. So what does that mean? That means our concatenation's actually backwards. Which, if we look at the process operator, I got these right, but for some reason I flipped this one around and said the value comes first. It's the current value comes first, and then we add the new value. Changing that inside of our logical line operator should give us the expected results. Let's not forget to switch it up here too when we concatenate or add. The value needs to come first, and then the current value needs to come second. Now, yeah, I need to make sure current value, okay, yeah, so actually it was this one. Value is string, so current value plus value. So I actually had the parameters wrong. The parameters were swapped. But now it's correct. So value, current value is matching up with value, current value in the parameters, and we've got current value coming first in both instances, then having the value added on after it. And third time's the charm. There we are. String concatenation is working. Another thing that you can do to make sure that you don't get any unexpected results is in the process operator. Let's make sure that if the variable does not exist, the only way that we create it is if we're doing a direct assignment. If we're trying to subtract or add or multiply or divide from a variable that doesn't exist, then we shouldn't be able to do that because we'll get an unexpected result. Sure, we'll create the variable, but we'll be assigning the value directly when we would really be expecting something else in the line. So else if OP equals the equals sign, so that we will only create a variable that doesn't exist if we're using it as a direct assignment. So with that, we've got variable declarations and modifications working directly within our dialog files, and we can see them updating and being managed directly through our variable store. So in the next video, we'll look at adding a new logical line for conditions where we can check these values against each other and against other values in order to determine what lines and what commands are allowed to execute at any given point in the visual novel. So we'll see you then.